Hey students, in this video we're going to be looking at our fourth purpose of a mechanism. But let's do a little bit of review. So far we have learned that sometimes mechanisms change the direction of movement, meaning when two gears are meshed together they're always going to rotate in opposite directions. We've also learned that sometimes mechanisms change the type of movement, and we had four different types of movements created in a mechanism: rotary, reciprocating, oscillating, and linear. Those are going to come up again today. We also learned that sometimes mechanisms change the speed of movement. You're going to find that the speed of movement has a lot to do with our new purpose of a mechanism, our fourth purpose of a mechanism, because sometimes mechanisms change the amount of torque or the amount of force available for a mechanism. So let's dive in deeper. First, let's check out our learning targets for today. First, I can understand energy and the use of a mechanism to transfer energy. We've had that on every single slide so far. Next, I can recognize how mechanisms change energy by transferring torque or force. So, transferring is just a fancy word for changing. Sometimes a mechanism is going to change torque or force. But I'm guessing many of you, when I read the word torque and when I read the word force, you need a little bit of help on that vocab. So let's jump into that. Force is a type of pressure we apply in a straight line. So a push or a pull in a straight line. That's represented really great in this GIF. This little guy is applying force to the square, compressing the spring. That is force. Here's some mechanisms with force in them. When we look at a vise, we talk about how much force a vise jaw is applying from one jaw to the next. There's so much force in a vise that you can actually smash a pencil into a bunch of tiny shards. Another mechanism that creates force is this rack and pinion. The reason is we're looking at what kind of linear output movement we have. Therefore, we have a change in force. And our third and final GIF is this toy up on the top that has a cam and follower. We have rotary motion going into this third mechanism, just like our two previous, but we have a different output type of movement. We have the toy reciprocating up and down as that hand crank is rotated, but we still are creating force in that reciprocating movement. Not all mechanisms are going to create force. Many mechanisms will create torque. Torque is what happens when we push or pull in a circular direction. I like how this set of arrows represents that circular movement. Torque is in a circular motion. So let's check out some GIFs that represent mechanisms of torque. A bike is a great example of a mechanism that creates torque. Anytime you want to bike up a hill, you have to increase the amount of torque that you apply to your bike so you can actually get your bike up the hill without having to jump off it and walk it up the hill. Another mechanism that creates a lot of torque is the worm and wheel. The worm and wheel mechanism has so much torque that you actually can't make your wheel gear spin the worm gear. It's literally impossible because there is just that much torque in the worm and wheel. And another mechanism is a bevel gear. You can see that this bevel gear has two different size gears. Therefore, we are changing the amount of torque in this mechanism. And the most common place that you have definitely witnessed the amount of torque is when you've tried to use a wrench or a screwdriver to either pull a bolt or a screw out or put a bolt or a screw in. You have to apply torque to that in order to make it work. Torque and force are something that you can add to a mechanism, but we can't do both. We can't apply both force and torque to a mechanism. And it's kind of tricky to calculate force in a mechanism, so we're going to be focusing on torque for this quarter because it's a lot easier to calculate. So how do we do that? How do we figure out if we're going to have a change in torque? Well, that happens when we are comparing our output gear to our input gear. Now, does that look familiar? It should, because we saw the previous slide, and we're going to see the next 3 slides are all slides that were in our previous video about a change in speed. We're going to get to more on that later. So a change in torque. How do we know when that's going to happen? Well, remember, we have to be looking at comparing our output gear to our input gear. We only will know if we have a change in torque by comparing the two. So does this worm and wheel change torque? Yeah, it does. And it all comes down to the number of teeth on the gear. The amount of teeth on this gear are different, just like we looked at when we were talking about a change in speed. A change in torque is going to count the number of teeth as well. Let's look at another mechanism. Let's check out this mechanism. This is the bevel gear. Again, we're going to figure out if this torque is changed by comparing the output gear to the input gear. And in our previous video, we found out that it doesn't matter on these 2 gears, which is the output gear and which is the input gear, because they're the same size. So does the bevel gear change torque? Nope, because the gears are the same size. So this does not change torque. We would say that torque and speed on this mechanism are going to be constant. There's not a change in gear size, so there's not a change in speed or a change in torque. So how do we guess if torque changes? Well, that's a bit tricky. Often, the thing about speed is we can see it change. There's a visual for us. But the tricky thing about torque is it is invisible. We can't see torque. It's just a theory. So how can we guess if torque is changing? With gear ratios. A review from last video. Last video we talked a lot about gear ratios, and we found out that we write a gear ratio one way, we calculate a gear ratio another way, and we say a gear ratio a different way. So we write a gear ratio as 4:1. We calculate a gear ratio as 4/1, and we say a gear ratio of 4:1. We're going to practice that more next time. Just a quick review, our new concept for today was how do we know if a mechanism is changing the amount of torque or force? That's our 4th purpose of a mechanism.